Hey guys, welcome to Programming Knowledge. In this video, we'll learn how to create our own data types using structures. But before that, let's first understand what object-oriented programming is. Now, object-oriented programming or object-oriented programming structure, as it's abbreviated as OOPS, it's nothing but a way of programming. So what we have been doing till now is called procedural programming, where you create procedures. Well, procedures are nothing but functions, and what we have been doing till now is we have been analyzing a problem. We have been breaking down the problem into a set of simpler problems, solving them, and then combining the result to give the output. Now, procedural programming works for almost in every problem, but when we want to generalize our solutions, procedural programming won't work. So let's take an example. Let's say I want to create a student registration program. Now, for student registration, I define a name, I define an age, I define arrays or let's say vectors when the user doesn't know how many records is going to enter, and then I will accept all the records and then save them. So that does the student registration process. Now let's say I want to create a program where it does student registration, but also it will give out some additional information. Let's say it's going to say who is the highest scorer of the class, right? Now what we do is we do all the same steps required for the student registration or the registration to happen, and then we write additional functions so that we can compute the highest score or whatever it is. Now to overcome this problem or to generalize this particular kind of problem solving methods, what we do is we create general objects. So objects are nothing but collections of similarly grouped features. Now here if you observe, student is an object, right? So student has all these features of registration, and then student has marks, age, name, and all the features which are required by student. And now what you do is you create such an object, or you create a class where all the features are grouped together, and then you use that particular class whenever you want. So if you remember from our pointers video, we have been doing something like hash include vector, where we include our vector class. This is a class where you have all the features defined inside this. Now when you want to use it, you just create one variable of the vector, so you just say vector int vec. Now what we have done is we have created an object of this particular class. It's just like creating a variable or a memory location of this particular data type, but in object oriented programming we refer to them as objects and classes. Now what we do is, in case you want to add some item into this, you just say vector dot pushback. So although you have so many methods inside this particular vector, but what you are interested in is just storing. So you just say pushback and then you just put the number you want to insert inside this. So this is how objects work. You don't know what is going on over here. You just know that if you do pushback, it's going to go inside the memory, and you've seen that. So there's a whole lot of code implemented behind this, but you can understand that this particular function is pretty much complicated to implement, and it has been implemented for us. You just need to use it. So you have a ready-made implementation, and you whenever you want to use it, you just say dot push, and then you can get the function to work. So that's how object-oriented programming helps us to overcome such redundancy. And when we create objects, we generally generalize the object so that it can be used for any type of problem where it involves that particular object. So that's about object-oriented programming. Now there are some technical terms you need to understand. One is data encapsulation. The second one is abstraction or data abstraction, and then third one is polymorphism. We'll be talking about these things in great depth at a later stage, but for now you can understand encapsulation as combining the features. So when you combine all the features which are required by a particular object, that is known as encapsulation. And abstraction is you show only what is required. So here if you see, the pushback function is actually an implementation of abstraction. So you don't know how this works, But what you can do is you can just put in a number and then it goes and sits in the memory. And to use such a function, it is not required to know how it works, so that is abstraction. And polymorphism is nothing but able to use a same thing in different ways. We'll be talking about this at a later stage when we are discussing about classes, but for now this should do. And we'll now get to defining our own data types, or as an object oriented programming we should be calling them as classes. Well, classes and structures are actually different things in C++. Also, they both are literally the same thing. So, in the implementation of classes and structures, you won't find any difference between them, but we'll just stick to the convention of using structures only to define smaller objects and then use classes to define somewhat bigger objects. Why these two things are there when these two things mean the same thing? Well, C was not an object oriented programming language. When C was introduced, it did not have this kind of capability to create objects as I've just discussed before. So, what it had is it had a capability to combine two or three data types and then store it as a collective data type. That's what it had, and that's what structure was for. So, when C++ was introduced, it was made to be object-oriented programming language. So what they did is they just extended this implementation so that it could hold collections of data types, and also it could perform features which I just discussed before. It can hold functions related to that particular object, or it can undergo inheritance and all those things. We'll be discussing about that later. That is how structure was designed. But when programmers were shifting from C to C++, they did not like this idea of using structures in a different ways. And moreover, many object-oriented programming languages which were introduced, they had the process known as classes. So for that, C++ introduced another thing called class, but this is just a history, it's just a convention, but you can use both of them in a similar way in C++, right? So now let's talk about structures, how to use them. Well, to create a structure, you just say struct and then the name of the structure, and we'll call this something, let's say student. Now this is a student class or structure. You can just call it whatever you want. Now this particular class, that is the student class or student structure, this can hold features. Now what all features does a student have? Let's say the student has a name, the student has an age, so int age. And what all can a student have? Let's say marks, so let's say vector int marks. Now this particular structure or this particular class is just like a data type. You can create variables from that. So let's say we want to create a student variable, you just say student and then let's say s1. Now you have created a student. If you want to assign a name, what you do is dot name and then you assign name. So let's say Tony, and then to assign an age, it's the same way, age equal to 10. And then if you want to assign the marks, it's just like putting it into a vector. So s1 dot marks dot pushback, sorry, pushback 10, and then s1 dot marks dot pushback 20, and all those things. You can almost use it just like you're using, but the thing is these variables are dedicated only to this particular student or s1. If you create any other student, let's say s2, this is a completely different object and all these things don't work here. So if I just say cout s1 dot name, you should be getting Tony as your output. That's because S1's name is Tony. And now if you change this to S2, you will be seeing that it is blank. So as you see here, nothing has been printed. So that's how objects come handy. Now if you want to just use the name of the student, you can just use the name from here and then you just neglect all these things. You don't have to just define the name, define the age and everything. You will have this file somewhere, and then whenever you want to do it, you just say hash include and then student in double quotes. We will be seeing how to implement this in the next video, but you can have this in a different file and then you can include this like this, and then you don't need all these things. You can just say student s1 s2 and then s1 dot name equal to Tony, and this thing will work. So that's how you can define your own data type in structures, or as I told you, this is nothing but a class, and you can have functions associated with it too. So let's say I want to create a function which will give me the average marks of this particular student. So what I do is I will create a function just like I create normally. So void average, and this doesn't take in anything because everything is defined inside. And to work on this particular function, what I do is I just say int sum equal to 0 and then calculate the sum first. So for int I equal to 0, I'll less than this marks dot size, and now this marks are for the particular student. This is not the class marks, but it's for this whatever student I'm accessing, so that marks will be considered over here. And then I plus plus, what I do is sum equal to sum plus that marks I, and in the end I just return sum over total. Now the total is nothing but 3 total, in the sense the total number of marks. So marks dot size will give me the total number of marks. Now here I can just call that function and get the marks. So if I just say s1 dot marks dot pushback something, so let's say 10, and then s1 dot marks dot pushback 20, s1 dot marks dot pushback 40. And now if I call s1 dot marks, sorry, s1 dot average, which was our function, now this should return us this average. Okay, that's because there's no student file. Okay, what does this say? Yeah, that's because I've put void over here, so int. And then now if we run this, we'll be getting 23 as our average marks. That's correct because what we have entered is 40 20 10, which is 70, and 70 over 3 is 23, so that's correct. So that's how you use objects in C++, and that's how you create your own data type using structures. And here if you see, this particular implementation is actually the example of abstraction. So here the user actually doesn't know what is the actual computation which is going on behind the screens, but he will be getting the average, and this is how you implement abstraction. And the whole thing is actually encapsulation. So here you have combined all the features. This average is a feature of a student, and the marks, age, name, all these things, these are just features of a student, and then you have combined all the features. So this whole thing is nothing but encapsulation. So in the next video, we'll be understanding how to use classes and when to use classes and structures. Well, you can use them interchangeably. There is no restriction on that. It's just by convention. As I told you before, classes and structures are literally the same thing in C++, but it's just that convention matters over here. When you're giving your code to somebody else to develop more, you need to strictly follow the conventions, right? So in the next video, we'll be looking at classes. Till then, happy coding.